Today we are going to discuss about the inverters. An inverter is one of the most important pieces of equipment in a solar energy system. It is a device that converts direct current DC electricity, which is what a solar panel generates, to alternating current AC electricity, which the electrical grid uses. In DC, electricity is maintained at a constant voltage in one direction. In AC, electricity flows in both directions in the circuit as the voltage changes from positive to negative. Inverters are just an example of classes of devices called power electronics that regulates the flow of electrical power. Looking at the characteristics of solar inverters characteristics are found within the datasheet of a solar inverter. So these characteristics vary from one inverter to another. They are never the same. So one of the inverter characteristics that we are going to look at is the inverter input voltage range and maximum voltage. Inverters are designed to operate within a voltage range, which is set by the manufacturer's specification datasheet. Inverter datasheet is very, very important because it is the one that has this information. In addition, the datasheet specifies the maximum voltage value of the inverter. Both the maximum voltage value and the operating voltage range of an inverter are two main parameters that should be taken into account when steering the inverter and the PV array. The PV designer should choose the PV array maximum voltage in order not to exceed the maximum input voltage of the inverter. At the same time, PV array voltage should operate within the input voltage range on the inverter to ensure that the inverter functions properly. So another characteristic we are going to look at is the inverter startup voltage. It is the lowest acceptable voltage that is needed for the inverter to kick on. So each inverter has a minimum input voltage value that cannot trigger the inverter to operate if the voltage is lower than what is listed in the specification sheet. So for your inverter to start, the voltage must always exceed the one that is listed in the datasheet. Another characteristic we are going to look at is the inverter and efficiency. Efficiency is the most important thing that also we should look at in the inverter. So as power is processed and converted from one shape to another, the solar inverters are expected to perform this task with the highest possible efficiency. This is because it is important to deliver maximum PV generated power to the load or to the grid. Typically, efficiency are in the range of more than 95% at rated conditions specified in the datasheet. So it is very important for the inverter to give you more of what is produced by the PV. So if your inverter is giving you less, then that inverter is not fit for that function. Another important characteristic we are going to look at is the inverter and ambient conditions. These are the extreme conditions which faces the inverter. So in most applications, the solar inverters are exposed to ambient conditions such as solar radiation, temperature, and humidity. So inverters must comply with the conditions of the location to make sure they can work under ambient conditions listed in the specification sheet. So you have to make sure that when you are choosing your inverter, you choose it according to the conditions where it is going to work. Lastly, we are going to look at the inverter and MPPT. MPPT means maximum power point tracking. Depending on the topology, most modern inverters have built-in MPP trackers to ensure maximum power is extracted from the PV array. Each inverter comes with a voltage range that allows it to track the maximum power of the PV array. It is recommended to match that range when selecting the inverter and the PV array parameters.